All right, how's it going?
What day is it?
It is Tuesday.
Oh,
Thank you.
it's not Friday.
It's not Friday. So I'm passing around a sign-in sheet. Please sign your name and fill in the little circle next to it. Okay? I know it's a pain, but it's a much bigger pain for me to fill them in for you. So you got to fill in the circle to get credit starting today. So do the circle. How many people downloaded Intellij and got it installed and running? Sweet, excellent, cool. That's good stuff. How many people had like horrible problems with Intellij and their laptop burst into flames and stuff like that? Okay, so anything we can talk about, or you think it's specific to you, or?
Oh no, actually it wasn't. I was just.
Okay, cool.
Instead of bursting into flames.
All right, yeah.
What are we doing Java version wise?
I use 1.8. If you use anything 1.8 or higher, it should be fine. I can go to we're not going to be doing anything that's specific to like 1.9 or 1.10 or whatever. So, but 1.8 should be fine. Some things in Eclipse and Window Builder broke when Java got to 1.10. That's part of the reason I abandoned Eclipse. But yeah, any one that works should be fine. And you can use the open source one. You can use the one from Oracle. They seem to be equivalent. Questions on PA2? So your deliverable is a set of classes, right? Yes.
So I do have a question with manipulating the word after the user types it in.
Okay.
So in the index utility part. So when you're trying to remove all the special characters and you're trying to change, like you're trying to remove the character in the word, how do you manipulate characters inside the word to just remove them? Because replacing I can do, but removing.
So here's some pseudocode. So initialize an output string to be just empty, and then go through each character in your input one by one, and if it's a letter, concatenate it to your output. Output equals output plus character. And when you're done, output is the cleaned up input string. Cool? Okay. There's things in the string class you can use also to replace, and you can use regular expressions and stuff like that, but this is always going to work. So you definitely need to turn in a tar file that includes indexutility.java, wordlist.java, and it doesn't show up here, but locationlist.java, right? Index utility really just creates this index utility object. It constructs it, and the only reason you're doing that is so that you can call this build index method in the index utility. Build index is the thing that reads from standard in, cleans up the input, and then adds that word at its current position into the word list. And the end result of build index is a word list, which is that linked list of words with reference counts that are each a linked list of integers, right? So you're creating an index utility just so you can call build index. Build index returns a word list, and then word list has a method called print, which will give you the nice clean output that you need to see the list of words and locations where each one occurs. And that's the user's main interaction with all the code that you're writing. So your build index is going to call methods inside your word list class. In particular, it's going to call the add word method to slam each word into that linked list. And the add word method takes care of saying, is this word a new word in our word list, or have we seen it before? And if we've seen it before, let's just update the location list. If we haven't seen it before, let's make a new node. Yeah?
So in the build index, when we're calling add word, would we do word list dot add word?
Yes. So build index. Let's see. Word list has an add word. Build index reads. Okay, so what does build index do? Read a word. Clean the word. Make it lowercase. Get rid of special characters and so on and so forth. And if you're left with anything, if it's not, if you read the word 1, 2, 3, when you clean it up, it's just going to be an empty string. You don't want to add that to your index. So clean the word, and if it's not an empty string, then you're going to say, name of your word list dot add word, whatever the word is and whatever the location is, and you're going to increment the location. And you're going to initialize your location to 1, and when you're done, you're just going to go back up here. There's your whole build index code. So initialize location to 1, well, that's integer location equals 1. Read the word, that's using, you're sitting inside a while loop, while scanner.has next, word equals scanner.next, that's how you read it. Cleaning the word, that's that thing on top, right? To create a cleaned up version of word, which is called output. And then use that variable dot equals, quote, quote, to see if it's empty, or check its length to see if it's 0, right? And if it's not empty, then you just, whatever the name of your word list is, you just call add word, give it the word, give it the location, increment the location. And that's the whole build index. And it takes almost nothing to write this. You don't have to do any really hard work, because all the hard work is happening inside this add word method. But when you get down to where you're writing the add word method, it's going to look similar. You're going to be doing things where you're really deferring to a lot of hard work that's being done inside your location list class or inside other objects. So yeah, that's basically build index. This is the sense in which Java or object-oriented design sort of encourages a top-down approach, because we can start making our high-level code without too much work, because we're just deferring to these lower-level routines. But when you're developing, sometimes you want to go bottom-up. You want to start off by making a linked list of integers, and then making an add to the end of the linked list method, and sort of build up all the pieces of this location list, and then move up and start working on the word list, which will use location list, and then move up and start working on build index, which will use the word list, and so on. So it can go back and forth. Oh, thanks. Anybody else need to sign in? Philip? All right, does that make sense? Cool. All right, let's play around with something. So the integer class, we talked about statics yesterday. The integer class has a bunch of static methods available. A bunch of which are called parse. So parse int, parse unsigned int. Parse int is a static method. It takes a string and it returns an integer. So if you give it a string like quote 25, right, 2 characters, parse int will return the number 25 as an integer. So it's doing the scanf thing like a %d format. And this is useful if we want to do something like this. Alright, so here's a Java program that will take a command line argument and multiply it by 2. Alright, so actually, let's make it slightly more interesting. Let's make something that multiplies 2 integers. Alright, so you're going to type in, you're going to say Java TC, you're going to type in 2 numbers, and it's going to multiply them together. And it'll show us, you know, the first number times the second number equals, and then it'll print out their product. Alright, so give me 2 numbers you want to multiply.
7 and 3.
7 and 3? Cool, 7 times 3 is 21. Awesomeness, right? Okay, so what about 7 times haha? Not very funny. We get a bunch of error messages here, right? Exception in thread main, Java lang number format exception for input string haha. So if we go back to this Java documentation, when you look at the description of parseInt, it has this thing, throws number format exception. Okay, that's this thing right here. And it's telling us that there's a possibility that this parseInt method is going to encounter an error. And the error happens if the string does not contain a parsable integer, like haha. So this is something that's called an exception. And exceptions are a common concept in programming languages and operating systems, CPU, computer architecture. So what is an exception? It's basically like a software interrupt. So if you've done 270, interrupts are things that occur. This input pin goes up to 5 volts, and the CPU says, hold on, I gotta go deal with this. And it stops what it's doing, and it goes over and starts running some set of code at some magic location, like 8 or 18 hex, to deal with the fact that this input pin suddenly raised to 5 volts. And when it's done, it does that return from interrupt, and it goes back to where it was. It was in the middle of playing Pong, and so it continues moving the little ball around. An exception is kind of the same thing, but instead of being triggered by a voltage on an input pin, it's triggered by some software condition. For example, holding down the control button and pressing the C button. That causes an exception, or a signal. So a lot of different methods can do what we call throwing an exception. Throwing an exception just means causing an exception. So requesting this kind of interrupt behavior. And it will perturb the execution of your program. We were supposed to print out I times j But instead, we came over here and we printed out these big long error message, and the program exited. That's how the exception got handled. Sometimes you don't want your program to do this when an exception occurs. And a classic example is if you're using parseInt and the thing isn't a valid integer. So there's a mechanism for dealing with exceptions. It's called a try-catch block. And here's the basic syntax. You can say try, curly bracket, and then put in a bunch of code and a close curly bracket. And if that code executes and no exceptions occur, everything's great. It just executes as if it were just a bunch of Java code. But at the end of try, you can say catch, and then we put something like a function argument list here. And the argument, the easiest one is just exception and some variable and another block. And in here we can put in a different set of code. And the way to think of this is you say try, you start executing this code. Suppose that right here an exception occurs. The system basically jumps down to this block of code. And as long as the exception that occurred is whatever type of exception we name here, it starts executing this code. And when it finishes, then it just continues from here on down. It does not go back and continue where it was. So it's a way to sort of jump out of your current execution stream down to a catch block and do something down here. So it's a number format exception that can be thrown. So let's try this. So there's a try-catch block. We're going to try to parse arg0 as an integer, and if it succeeds, we're just going to end up down here where the cursor is blinking. But if that conversion fails, we're going to go into this catch block because the exception will be a number format exception, and we'll go ahead, we'll print out this message, and we'll just return. Yeah?
So instead of just looking, like we did in C, we would just look at our string and see if it matched what we wanted.
Mm-hmm.
Instead, we're just going to wait and see if the system gets an error. And if
Yes.
the error we're accounting for, we just...
Yep.
Okay.
Yeah. And we don't always want to do that, right? If you have a different way of knowing if you're going to get an exception, don't just use a try-catch block, because these can become a really bad crutch, right? Every time that you're about to do something, you're just going to put it in a try-catch block and let the system handle it. You don't really want to do that. But in this case, parseInt, there's really no way to know if it's going to, if arg0 is a valid integer or not. We could check it to see if it's got a minus sign in the front and digits and so on and so forth. But this is an appropriate use of try-catch. All right, and we can do the same thing for J. And if both of those conversions succeed, then we'll go ahead and we'll print out I times J. Okay, this is not going to compile. It's going to complain that it doesn't know about I and J, because this worked fine when we didn't have a try-catch block, but if I say integer I inside this, that I is local to this context, right? So there's scoping of variables, and I belongs to basically anything inside that set of curly brackets. When I come down here, that has no connection to this integer I up here. And a lot of times you have code, it works great, you try to put it in a try-catch block and you start getting messages about can't find symbols. That's usually what's going on. So the fix is pretty easy. Declare I and j outside here. And we'll encounter this again and again. Yeah?
When you do that, the first one and the second one are going to be different.
Which first one and second one?
First I and second.
If I said integer I in here, then that would be different from this integer I. But if I just say I, then it's going to refer to this one, which is local to this method, right? But it's kind of global throughout this method. Right, so the scoping of this variable is from here down to here. So now when I use I down here, it's going to be that I that I parsed. All right, so let's try that. So 7 times 3, we didn't break anything. 7 times haha. Haha's not a valid integer. Goodbye. Good yai. Alright, so now I'm not getting the exceptions. But this will still generate an exception. Because what's the problem here?
You're accessing unwrite an index outbound.
Yeah, I'm trying to access my argument list and I don't have any arguments specified. So if I go down to line 7, right, this is the line that's failing. Well, args bracket 1 doesn't exist because I didn't specify any arguments on the command line. Now I could catch that in a try-catch block also, but that's kind of a heavy-handed use of try-catch. What's the better way to know if arg0 exists? Just check the length of this array. So arrays, you check the length with just dot length. It's a field, it's not a method like with strings. So it's just dot length instead of dot length paren. Alright, so that's how we'll check the number of arguments. We could use a try-catch. We could make a try-catch block and just say, you know, I equals, or, you know, string temp equals args bracket 1, and see if it throws an exception, and if it does, our catch block, right? But exception handling is fairly expensive. It takes time, takes a lot of steps. So if you have a way to check a condition without using exceptions, do that first. If you don't have a way to check it, then go ahead and use a try-catch. So there's my usage. There's my other usage. And there you go. Questions?
Especially like fguess and scanf and scanf PC.
Yeah, so this parseInt is very much like an scanf, right? And since we're doing parseInt, it's like scanf with a %d. if you look in the double class, you'll find a parse double method. It takes a string, treats it as a double, so that's like an scanf with a %g or a %f. And I think so parseInt can also be called with two arguments, a string and a radix, and that lets you parse hexadecimal, binary, things like that. So radix has to be an int. So if we use (2), this should let us multiply binary numbers. So there's 7 and 5. So 7 times 5 is 35.
So 2 does mean the base 2.
Yep, means base 2. If you do 16, it'll take hex, and then you can put in A through F also. I don't know if you can go above 16.
I think it's 2 to 36.
It's what?
2 to 36.
Oh, really? So you can do like base 36? Cool. Okay, because A through Z. Well, that's kind of fun. Sweet. All right, let's see. So this catch block, we wrote catch parentheses number format exception. And this is only going to execute this code if the exception that we generate is a number format exception. Well, exception is a class. And there's lots of different types of exceptions that we can have. And there's a whole lot more than just these. And so when you look at a particular set of code, a particular method, if it can throw exceptions, it'll tell you what exception or exceptions it can throw. And you can put those into your catch block. But there's a hierarchy of exceptions, right? So number format exception might also be considered some other type of exception, which might be some other type of exception. And there's a general type of exception just called exception. Right, an exception catches any exception of any type. So here's what we can do. If I just say catch parentheses exception variable, it'll catch any exception. And that might be okay to do, or it might be dangerous. For example, if I didn't check for the number of arguments and I got that array index out of bounds exception, that would also bring me down here. But if you know what you're doing and you're pretty sure there's only one possible type of exception, it's usually fine to just catch on an exception. Alright, so haha is not a valid integer, goodbye. So what is this variable var that we're setting, that we're naming inside this catch piece? Var is an exception. Right? Everything's an object. Var is an object of type exception, which means it has a bunch of methods available. So it has methods like toString, of course. It has methods like print stack trace. It has methods like getMessage. All right, so inside my exception block, I could do the following. Let's just print out that variable var, which is an exception. Right, exception is, and it tells me a nice readable description of what that exception is. Java language number format exception. And there's this print stack trace method, which will show me who was called from where. So I'm going to take again that argument var that was passed to the catch block, and I'm going to call the print stack trace method. After printing out the message stack trace. And that gives me the rest of the output that I used to see. So this was the toString version of that variable, Java lang number format exception for input string, and this is the result of calling stack trace. So if I want to know where the error occurred, it occurred at line 15 in my tc.java, and that called integer.parseInt, and at line 580 in integer.java, that's the source code for the integer class, it made a call to this number format exception.java line 65, which generated that exception. So you have the ability to catch errors when they occur and then do a fair amount of analysis on what caused the error and what the context is that you're in when that error occurs. Sometimes this is useful, sometimes not. For things like PA1 or PA2, not terribly useful. As we get more sophisticated and we start doing multi-threaded programming, or we start dealing with networking stuff, or some of the GUI stuff, right? There's going to be more and more cases where we can have unexpected situations, which might sometimes produce exceptions, errors. and then it's going to be useful to be able to pick those up and analyze them using some of this machinery. So questions about that? All right, so we'll come back to this throughout the course as we do other things. Every time we have something that can generate an exception, we'll come back to this and we'll start using try-catch more and more. This is another thing that IDEs will do for you. If I were to write a set of code that can throw an exception, a lot of times the IDE will say this might throw an exception, would you like a try-catch block? And you say yes, and it will write all of that try-catch code for you. You know, an outline for it. It'll put in the try before and a catch for an exception, and then let you fill in the details that you want. All right, so we are almost good to go to Intellij. Oh heck, let's start Intellij. We'll talk about class extensions another time. Let's just bring this up, because I want to spend tomorrow playing with this. So I'm on Linux, and I don't remember what weirdness I ran into when I installed Intellij, but I ultimately just made an alias, which executes a shell script and ignores all of the output. And this takes a little while to get going, as a lot of IDEs do. And if it doesn't come up quickly, we'll talk about something else. There it is. All right, so there's my startup window. So I'm going to say create new project over here. By and large, I take defaults on things. You can play around with options on here and see what they do. That's a good thing to do, but you just kind of get on the air and do a hello world. I'm just going to take defaults. So the default is I'm trying to create a Java project. That's good. I'm not going to use any of these additional frameworks, so I'm just going to say next. And I'm not going to create from a template, so I'm just going to say next. And I am going to specify a project name. The first time you do this, you want to specify a reasonable project location. Make sure this is somewhere where you don't have anything else, and it's somewhere that you back up regularly, because this is where your projects are going to go by default going forward. So for mine, I put it under my backup area, under idea projects. So what should we call this? Let's call this 223A. So that's my project name. And it gives you tips on startup, which you can read. So here's 223A, right? Every project that you make is going to go into its own directory, right? And that's what I've been encouraging you to do from the command line also. So if I look in 223A, it's got an IML file. You don't want to mess with that. It's got a source directory, which will have the .java files we end up creating. And it'll end up with a bunch of other stuff in here, right? Generally, you don't want to do any tinkering with any of these directories, right? Let Intellij manage it. But if they're in a backup area and you back them up, right, that's good. All right, so here's the window I have. I have my project up top, and that's currently open. It's called 223A, and then just a bunch of open space. Okay, so let's make a hello world. We got 6 minutes to do this. So I'm going to double click on 223A. I'll see a folder that says source. I'm going to right click on source, and I'm going to say new, and I'm going to say new Java class. Okay, pick a name for the class. I don't know. I'll just call it my main class. And I'll say OK. And it creates 2 lines of code for me. So I'm going to go ahead and make a public static void main. I'm going to have to make this font bigger for class. So this has the feature of, doing extra typing for you. So as soon as I type a left bracket, it typed a right bracket right next to it. And as soon as I hit enter, it will move that right bracket down to a separate line, and it will indent so that I can begin typing, and I'm indented automatically. To me, that's annoying. That gets in my way all kinds of ways. But most people like this. Most people feel like it makes them faster and more efficient. So it's up to you whether this is good or bad. There's no way to turn it off in Intellij. You can turn off some of it, but some of it is so kind of ingrained in the minds of the developers that they don't even understand that it's doing something like auto-indenting. And there's no way to turn it off, at least last time that I looked. So you got to kind of live with it. But if you like it, even better. So as you start typing, right, it also shows you possibilities. So let's go back and do this again. So I start typing system, SYST, and here's everything that I might be typing that begins with SYST. And you can hit Control plus to choose the selected suggestion and insert a dot afterwards, or you can click on it, or you can ignore it and just keep typing. So I'm going to ignore it. I'm going to say system dot, and now here's all the things that come after system dot. And if you can't remember the name of something, you can scroll through here and say, oh yeah, I want a system dot set properties, right? Or you can just keep typing. So, and there's print line, parentheses, well, without the parentheses. It's showing me all the things that I could put after print line. Right, integers, characters, strings, etc., etc. So I'm just going to put in a parenthesis. It fills in the right parenthesis for me. I put in a quotation mark. It fills in the closing quotation mark. I'll say hello. And there's a little red squiggle at the end of the right parenthesis, and I can hold my mouse there, and it'll say I'm expecting a semicolon.
Does it know that because it's compiling as you type?
Yes. Yeah, it's doing all this stuff while you're typing.
But is it calling Java C again?
It's doing something equivalent, but I don't think it's actually calling Java C. I think it's got smarts inside about how to compile. And it's not too bad. When I was doing this last night, I was taking like 105% of my CPU on startup. But it seems to be pretty efficient. All right, so I'm going to come over here to the end. I'm going to type in my semicolon, and I've got a little light bulb, which is something else that it's unhappy about. We're not going to worry about that for now. Okay, so there's our hello world program. I'm going to hit the little hammer over here to build, which is going to compile everything. And down here it says it's building, it's parsing. Okay, it should be compilation completed successfully in 7 seconds. So normally I'll have a little run button over here. The first time you do this, you don't have a run button, so you come over here to run, and you come down here and you say run, and it'll say, what do you want to run? And you have to tell it, I want to run my main class. So you got to name the class that you want it to execute. So I'm going to double click that. It's going to run, and there's the output, and it says hello. And if I change my program, I can come over here, I can hit the run button, and it'll go ahead and it'll rebuild and it'll execute and it'll go ahead and run, and there's my output. Once you get this up and going, it's really, really rapid development. Okay, that's classic with IDEs. You got to install it, you got to figure out the details, you got to set up your initial save directory and so on. But once you've got a project going and you're working on it, you want to make a change, right? Type in your change, hit the run button, and it goes. And you can't remember how to use a scanner, right? So let's say I want to do scanner equals new scanner, and it's underlining this, and it's saying Java util scanner, and hit Alt plus Enter. So I'm just going to hold down Alt, press Enter, and it will let me import this. So I want to import scanner Java util. Double click that. There's my import statement. Okay, there are tons of things that this will do for you, and you can, you know, spend a few years getting really, really proficient at Intellij, and it will feel like you're barely doing anything. You're just kind of thinking what you want, and it happens. Okay, so we're gonna kind of scrape the surface of it, but you can definitely go very, very deep and get a lot out of this tool. All right, so we'll play around with this tomorrow. We'll start making some GUIs. Yeah. Yeah.